Hello, I'm Ken Wickham, and today I'll demonstrate how heat transfer affects a Pittman DC motor and discuss its performance specifications. There are three ways that heat is transferred from a motor: conduction, convection, and radiation. Conduction is where a heat source transmits heat to another object by direct contact. Convection occurs when a heat source transmits its heat to another object via a moving gas or liquid. Radiation of heat away from an object can transmit to another object without direct contact or through a circulating medium. This last method is negligible for our motors. Pittman motor data for the 6000, 8000, 9000, and 14000 series is based on tests where our motors are suspended by wires in standing air at room temperature, or 25°C. The rotor is locked to prevent rotation. You can see the thermal probe indicates the internal temperature of the armature. This setup minimizes the amount of heat transferred due to contact directly or through a medium. Heat is generated inside the motor primarily by resistance to current in the windings. The test is stabilized when the maximum winding temperature, 150°C, is reached. Additional heat is conducted through the connection contact between the motor shaft and coupling. In this case, a fan blade assembly has been set screwed to the shaft. You can see this reduced internal winding temperature by 12.8°C. Since the motor is now stabilized at a lower temperature, I can increase the load. This will cause the temperature to rise again. Once the winding temperature has stabilized around 150°C, I can see that this motor is now able to draw 15.4% more power and produce 5.7% more torque based on current. Once the motor is mounted to a plate, additional heat transfer will occur. Most of the heat is conducted through the mounting contact between the motor and plate. You can see this reduce the internal winding temperature by 25.6°C. Since the motor is now stabilized at a lower temperature, I can increase the load. This will cause the temperature to rise again. Once the winding temperature has stabilized around 150°C, I can see that this motor is now able to draw 52.7% more power and produce 13.5% more torque based on current. Since most customers will mount a Pittman motor in their application where it can transfer heat to its surroundings, the catalog data will usually be conservative compared to the actual results. In the case of this specific example, I've shown that our motor is able to receive 30% more power and produce 20% more torque based on current. This strategy ensures that a customer's motor is designed for worst-case conditions. Contact us today to get started.